The noble gases are the most stable group of elements. They are all colorless and odorless. With a few exceptions, they are inert, meaning they do not readily react with other elements. Helium is the second most abundant element in the universe, but it is rare on Earth. Because it is so light, it easily escapes the atmosphere. Most earthbound helium is in natural gas deposits deep underground. Neon is best known for the colorful lights of Broadway and Las Vegas. Not known to form any compounds, neon is completely inert. Argon is the third most abundant gas in the Earth's atmosphere. It is often employed to create inert environments for industrial processes and light bulbs. Krypton is occasionally combined with argon to create unreactive atmospheres for industrial processes. It is also used for lighting in high-speed photography. In 1962, scientists were able to form a compound between xenon and fluorine, making xenon the first noble gas to react with another element, and proving that even the noble gases can form compounds under the right conditions. It is most commonly used in high-powered and strobe lights. Radon is the only radioactive noble gas. It was first observed as a decay product of radium. It may present a health hazard if it is found inside a house. To understand why it is so difficult for the noble gases to form compounds, let's take a closer look at the periodic table. The elements are listed in the order of their atomic number, which represents the number of protons in an element's nucleus. In its ground or normal state, the nucleus is surrounded by a number of electrons equal to the number of protons. As the atomic number increases, generally so does the size and mass of the atoms. Reading from top to bottom, each horizontal line on the table is called a period. Each period represents the number of electron shells normally occupied by an element's atoms. For example, a krypton atom has 4 electron shells, so krypton lies in period 4. Meanwhile, a radon atom, in period 6, has 6 electron shells. Reading across the table from left to right, the vertical lines of elements are called groups. Elements in a group have the same number of electrons in their outermost electron shells. These are called valence electrons, and they dictate how elements interact. Elements in the same group generally interact with other elements in similar ways. None of the elements greater than atomic number 83 are completely stable. All of them, including radon, are radioactive. All the noble gases reside in group 18 because each one has a full valence shell. A helium full shell has 2 electrons. All the other noble gases have 8 electrons in their outermost shell. Because the noble gases need no electrons to be stable, they rarely react with other elements. Only the heavier noble gases form compounds, and then only in special laboratory conditions. Krypton, xenon, and radon will react because as you move down the group, an atom's hold on its valence electrons becomes weaker. The stability of the noble gases is actually a useful property. These gases are used in many situations where an unreactive gas is needed to maintain a safe and constant environment. Industrial processes such as welding rely on atmospheres of noble gases to prevent explosions, and vintners use argon to prevent wine from turning to vinegar. All of the noble gases will conduct electricity. Neon may be the most familiar gas used for lighting, but argon, krypton, and xenon also fluoresce, and combined, they create many different colors.